Good morning, algebra students, or good afternoon, depending when you had class. Just for the week's agenda, we are going to have a quiz on solving equations on Wednesday. So we have today, we have a practice quiz tomorrow, and then we're having our quiz. And then our test is going to be this Friday. So you get your quiz on Wednesday, and then you get that back on Thursday, your review for the day, and then Friday you're going to walk in, you're going to take the test. So be conscious of what's going on and make sure you're studying accordingly. So we've already kind of done some of these problems, but we're going to dive into a more formalized, a more formal way of looking at these problems. So this is something you're going to write down in your notes. So combine any like terms is going to be the first step you do when solving an equation that has variables on both sides. So combine your like terms. Now you're going to do this throughout the entire problem. So it says combine like terms as number one. Well, you're going to do number one, then you're going to do step two. Then if you do step two and there's like terms, you combine them. You go to step three. If there's like terms, you combine them. So combine like terms goes through the entire problem. So copy these down and then move on. So pause right here and then keep going. All right, I'm assuming you have these written down now. My smart board is being a little weird, but we're gonna go ahead, we're gonna combine any like terms for example one. Looking at example one, I don't have any like terms, and I'm gonna draw my line because I'm looking on the left side of the equal sign and on the right side. So on the left side, there's no like terms. On the right side, there's no like terms. So now I'm gonna check, do I use the distributive property? And it doesn't really look like it, but I am indeed going to be doing that. So this negative right there needs to be distributed to both the x and the 4. What that really is saying is negative 1, x plus 4. So we do need to distribute that, and we're just drop down the negative 8. This is going to be negative x minus 4. Now, again, we look if we have any like terms. We don't. So we move on from that. And step 3, it says move the variables to one side. Well, I only have one variable right here, so I don't have to worry about that. So that's check. So I pretty much checked everything off, okay, so far. It says move constants to the other side. So this is really doing a two-step equation now. So plus 4, negative 4 plus 4 is 0. So that's gone. And I end up with negative 4 over here. That equals negative x. So we're done there. And then the last thing we do is we solve the one-step equation. Now, some of you may think this is done, but again, just like at the beginning of the problem, this is a negative 1 times x. So we are going to divide by negative 1, divide over here by negative 1, and we're left with 4 is equal to x. Okay? So that's example 1. Example 2. Now in this case, we have k on the left side of the equation. We have k on the right side. So we're going to have to do a little bit more work than we did in that last problem. Again, though, I start with step 1. It says combine any like terms. I have no like terms on the left side. I have no like terms on the right side. Now I'm going to check to see if I need to use the distributive property. I do on the right side of the equation. I'm going to distribute that 6. So I'm going to have 6 plus 18k. And on the left side of the equation, I haven't changed anything. So far, step 2 is done. Step 1, like I said, it's repetitive, so I'm not going to check it off. Step 3, move the variables to one side of the equation. So I'll do that. And looking, this is where I get some choice. I can move negative 6 to the right side. I can move 18k to the right side or to the left side. So I have two options there. I'm going to go ahead and I'm going to add 6k, and I'm going to add it to 18k. And here's the reason why. I want my variable to be positive. So in the last problem, we divided by negative 1. If my variable is positive, I don't have to do that. So that saves me a step. So that goes away. I get negative 18 is equal to 6 plus, and this is going to be 24k. And now I have moved the variable to one side, okay, of the equal sign. When I say move to one side, it's always in reference to the equal sign. And then our next step is said to move constants to the other side. So I'm going to put a check mark there because I'll subtract 6 over here, and I'll have negative 24 equals 24. Okay. So I solved the one-step equation now. So I'm going to put a check mark there because I'll divide by 24, and get negative 1 equals k. You could also write k is equal to negative 1. Both of those are okay. Now, step 4 and 5, you might think, well, we've already been doing this for a while. This is really just solve a two-step equation. That's what step 4 and 5 really represent. But if you have a checklist, it's always easy to just go through and do that. So I put them up there. If you would rather just have 4 steps, and instead of 4 saying move constants to the other side, you could just go ahead and say solve two-step equation. That would be fine too. All right, so this is a decimal, okay, just so we're conscious of that. And now I don't have my steps on the side. I'm expecting you guys to have those. But step 1 again is to combine like terms. I don't have any that I can combine. So I'm going to go ahead and start distributing because I do see that I can do that. Now, I don't like decimals that much. I like fractions. So I'm going to say this is 1/2. 4x minus 2. Same thing as it was before, just in a different representation. Then I'm going to go ahead and distribute. So I get 2x minus 1. Now, again, we have an option here because we're going to move our variable to one side of the equation or the other. I can move it to the left side or to the right side. If I think about moving 2x to the left side, that's going to give me a negative x. So I'm going to move my x to the right side, and I'm going to be left with 7 is equal to x minus 1. Okay, and then now it's going to be typically solving a two-step equation, but x has no coefficient, so it's just going to be a one-step. And so we're just getting our constants, our numbers without variables, to the other side. So I'm going to plus 1 and plus 1. All right. Now our last one has a bunch of stuff there. Step 1 again, it's always combine like terms. And this time I actually can combine like terms right away. So drawing my line down, I look at the left side, I have 10d minus 6, no like terms there. But on the other side, I have 4d minus 15 minus 3d. Well, that negative 3d and the positive 4d are like terms. And one thing I want to point out is when we are combining like terms, it's really just adding the coefficients. So it's just adding integers together. So 4 minus 3 is 1d minus 15. That's equal to 10d minus 6. All right, I'm going to move my variable. So I'm going to subtract 1d. You could just say subtract d. Got a step ahead of myself. I'll show all those steps. I'm going to go ahead and add 6 to both sides. And I will end up with d equals negative 1 because we divide by 9 here and divide by 9 there. So just to kind of go through those steps again, sometimes you're going to combine like terms right away. Sometimes you won't. Sometimes you will use the distributive property right away. Sometimes you won't do that either. Like in this problem, for example, there is no distributive property that was used. And then really our goal, we've been doing 1 and 2 step equations for a while now. It's really just adding that combining like terms and the distributive property on top of it. So we've done all the processes now. We just got to get comfortable. So we have a couple worksheets. And so worksheet 3.4, you can go ahead and do the odd problems. And then for the other worksheet, multi-step equations, you can do the even problems. Now, I've printed an answer key for both, but the answer keys are also in the learning plan as well. And as I mentioned before, we have a quiz and a test coming up. If you want to see that in the details, you can go ahead and look at the learning plan as well, and it's right there. All right, have a nice day, everybody.